Welcome to Manifested Publishers. My name is Mr. Mariga, and I'll be teaching you advanced management accounting. So today we are going to continue with the topic we had started previously or in previous sessions on planning and decisions making and planning and decision making, where we had talked about cost volume profit analysis under conditions of uncertainty. Specific items we discussed during the previous sessions is number one is cost volume profit uncertainty model using expected value approach, using simulation approach. So today we will discuss using sensitivity analysis and maybe using statistical analysis. But let's start using sensitivity analysis. So C is sensitivity analysis. Now, sensitivity analysis here is basically where you want to measure or you want to identify or to determine the percentage change in factors affecting profits as a reason of changes in what? In profit. Let me explain that. You want to determine how sensitive one of the profit is as a result of changes in what? One of the factors affecting what? Profit. And we can have an illustration given your selling price per unit is 200, your variable cost per unit is 50, your fixed cost in total is 200,000, and your current sales is how much? 2,000 units. Then required, can say required, compute the percentage change in each input, variable, in each input variable, which will cause profit to drop to what? To zero. So determine the percentage change of each variable which will cause the profit to drop to what? To zero. We can start by determining that and realizing that your profit, which we denoted as P, as pi rather, is P minus V. You multiply by your units minus your what? Fixed costs. Minus your fixed cost. So you want to analyze what change will the selling price change by for the profit to be zero? What percentage change will the variable cost change by to give you a profit of zero? The fixed cost and also the units. Let's start with A, percentage change in what? In P, in selling price P per unit. Remember, P means your selling price per unit. Your current profit is going to be zero. You have to determine a new selling price. Your variable cost is 50. Your units sold are not going to change, will be how much? 2,000 units minus a fixed cost of 200,000 minus a fixed cost of 200 what? 1,000. So this will be 200,000 is equals to 2,000 P minus 10. That is what? That will be your what? Your equation. That will be your equation. What we've done, we've simply taken 200 to the other side then open this bracket by taking 2000 by P, that is 2000 P, then 50 by 2000, that should be 100,000. Then you're going to say 300,000 is equals to 2000 P. So that means your new selling price for it to result in a profit of how much? 0, means your selling price will be what? 150. But remember, we want our percentage change. So you're going to take the current or your new selling price, which is how much? 150. You subtract your original selling price of 200, divide by what? Original selling price of 200. Then you multiply by who? 100%. You multiply by 100%. So it basically means that for your profit to fall to 0, the selling price will need to reduce by what percent? 25%, if all the other factors are not being done what? Affected. That is a percentage change in what? Selling price. Let us also do the same for variable cost. Percentage change in variable who? Cost. Again, you want your profit to be 0. All the other factors apart from what? Variable cost will be the same. Your original selling price is 200. You want a new variable cost. How many units are you selling? You're selling 2000. And your fixed cost is still originally how much? 200,000. 200,000 is equals to 2000 by 200. That will be 400,000 is equals to 200,000 or 2,000 of what? V. So 200,000, if you work it out, is equals to what? 2,000. So your variable cost will be how much? 100. So for your for your variable cost to give you a profit of 0, it will need to be set at what? 100. So let's determine our percentage what? Change. Your percentage change, which will be your original, or rather your new 100 minus the original, which was how much? 50. Then divide by the original, then times what? 100 times 100. So therefore, that is 50%. 50%, which basically means that your variable cost will have to do what? To increase by 50% for the cost to do what? For the cost to have an impact of making the profit to be what? 0, of making the profit to be 0. That is your variable cost. Then the other factor that we want to analyze, say percentage change in what? Units. So percentage change in what? Units. So we want to identify what change will result in profit being what? 0. What change in units will result in profit being 0. So you will say 0 is equal to, your selling price is 200, your variable cost is 50. The units, you don't know, but you know your fixed cost is how much? 200,000. So therefore, your units will be 200,000 divided by who? 150. Divide by 150. 33.33 units. So for the company to gain a profit of 0, which is where your revenue and your cost are equal, you have to sell how many units? 1333.33. 1333.33. Let's now identify the percentage what? Change. Your new units minus your original units, divide by your original units, times 100% times 100%. So we want to take the percentage change percent. So it basically means what? That your units will have to fall by 33.33% for the profit to be what? 0. Let's analyze your fixed costs. Percentage change in fixed costs. Your percentage change in fixed costs. Again, you want a profit of 0. Your selling price will be as original 200. A variable cost of 50. Your units are 2000, but you know you don't have your what? Fixed cost. So therefore, your fixed cost will be what? 150 by what? 2000. When you work that one out, that will give you 300 what? 1000. What we've simply done, we've taken this fixed cost to the other side. Then open that bracket. Alright, so your percentage change in fixed costs will be your new fixed costs minus your original fixed costs divided by your original fixed costs times 100. So it basically means that your fixed cost will have to do what? To change by 50%, or it has to increase by 50% for the selling price or for the profit to be equal to what? To 0. To be equal to 0. That is what we refer to as sensitivity analysis. Simply analyzing the percentage change in one variable as a result of another variable. All right. Sensitivity analysis is that. Let's go to the next method known as statistical analysis. The next method is what we are referring to as statistical analysis. Statistical analysis. Now, statistical analysis here simply involves using statistical measures to determine how cost volume profit is reacting, or how a product is reacting. And the following are the common measures used. The measures of statistics. The first measure of statistical analysis that we could use to analyze cost volume profit under conditions of uncertainty is what we refer to as expected value. Your expected value, which we have already even covered here, and your expected value, we said, how do you determine your expected value? You simply take X, you multiply by probability. It could also be given by the summation of X divided by N. So for the second formula to be used, you only use it when you don't have what? Probability. The second measure of statistical analysis of CVP under conditions of uncertainty is what we refer to as standard deviation. Standard deviation, which you denote as that. So the standard deviation here is given by the summation of probability, X minus the expected value. You do what? You square X minus the expected value, you square. In case you don't have probability, this is the formula you use. N minus 1. N minus 1, where N simply represents the number of observations. N is the number of what? Observations. The third statistical measure is coefficient of variation. Which you simply denote as CV. So CV, you simply say it is your standard deviation divided by your expected value. Your standard deviation divided by your expected value. Your standard deviation by your expected value. We can have an illustration. We can have an illustration to guide us on statistical measures of CVP. You can have an illustration that we will use to do this question and to illustrate statistical measures of CVP. Statistical measures of CVP. And the illustration will read as follows. The illustration will read as follows. It will read as follows. A company is considering mutually exclusive products. Exclusive products. And A and B. The following information has been provided. We can start with product A. Product A, you'll have your probability and your profit in shillings. Your probability and your profit 0.1, 0.7 and 0.2. 10,000, 20,000 and 30,000. Product B, have your probability and your profit in shillings. .4, 0.5, 0.1, 10,000, 20,000 and 30,000. Then the requirement here, using statistical measures of CVP, advise the management of a company, on the product to produce. On the product to produce. So they want us to analyze, using the statistical measures, which of our two products, whether A and B, we should do what? Produce. We should produce. We can start by getting your expected value. And we know that is given by your probability times who? Times the profit, or the variable. In this case, the variable is your profit. So 0.1 by 10,000 0.7 by 20,000, 0.2 by 30,000. Your expected profit for B, for product B, 0.4 by 10,000, 0.5 by 20,000, 0.1 by 30,000. We need to determine this. This is 1,000. That is 14,000. And that is 6,000. So that the expected value there will be what? 21,000. That must be 4,000, 10,000, 3,000. So that is 17,000. So using the expected value, product A, product B, and your advice. Product A, product B, and your who? Your advice. So using the expected value approach, using the expected value approach, product A had an expected value of 21. Product B had an expected profit of 17. So the product you want to produce in this case will be the one with the highest expected profit, which will be product A. So you advise them to produce product what? A. Let's determine our standard deviation. So we introduce your probability x minus x bar. You do what? You square. 0.1, 10,000. Your expected is 21,000. Then what do? We square. 0.7, 20,000 minus unexpected of 21,000. We do what? We square. 0.2, 30,000 minus unexpected of 21 squared. Then what do? We square. The same case is true here. That is how you get your deviation. Your probability is 0.4. 10,000 minus unexpected of 17,000 square. 0.5. 20,000 minus unexpected of 17,000. But remember to do what? To square. 0.1. 30,000 minus unexpected of who? 17,000. And what do? You square. You square that. And once you're done squaring, you must get your who? Total. So let's do this together. 10,000 minus 21,000 squared plus 0.7, 20,000 minus 21,000. What do? You square plus 0.2, 30,000 minus 21,000 squared. But remember, you must confirm your answer so that you see whether it is what? Accurate. This, I believe, should be 29 what? Million. 29 million. Then let's talk about the other products. B. Let's determine this the variation there of product B. We're still comparing the actual minus your expected, then you multiply by probability of each. That is 41,000. But again, we've said Please make sure you confirm. Please make sure you confirm for accuracy purposes so that you don't make a mistake. Please always confirm your answer so that you don't make a what? A mistake. All right. Now the standard deviation. Standard deviation. So there, what do you do? So the standard deviation of 29 million. And the standard deviation of who? Of 41 million, or the rather square root of 41 million. This I can see is 6403.12. This is 5385.16. So you're going to tell them to use product what? A. Why? Because it is the one with the least standard deviation. Then your coefficient of variation, you're going to take 5385.16 divide by 21,000. 0.256, then 6403.12 divide by who? 17,000. 0.377. And here you look at the one with the least coefficient of variation, which in this case you're going to say it is product what? A. Product A. Why product A? One of the measures of risk is coefficient of variation. One of the measures of risk is coefficient of variation. So you look at the one with what? With the lowest risk. With the lowest risk. And those are what we refer to as statistical measures or statistical analysis of CVP under conditions of uncertainty, under conditions of uncertainty. So this, we are done with it. Remember, we're going one at a time. One at a time. Let's now talk about number E, or the fifth method of dealing with CVP where you are uncertain, which is probability tree diagram. Probability tree diagram. So you will allow me to do away with this, your probability tree diagram. Your probability tree diagram, is where you simply draw a tree diagram, almost similar to when you're dealing with probability trees. From your mathematics, you must have done probabilities. So we'll be drawing a similar tree. And for us to be able to draw that or to illustrate that, there are certain items we must be given. One of the items that you must be given is your probability. You must be given your who? Probability. And you must be given your variables. You must be given your probabilities and your what? Variables. Your variables here may be labor cost, maybe material cost, maybe direct expenses, variable overheads, maybe the variable cost, maybe the fixed cost, maybe the units to be produced and sold. But they must give you some variable that you're going to represent in your tree diagram so that it can help you to get a what? A decision. For example, if they're asking you to draw a tree diagram to determine your contribution, you know your contribution is the difference between your selling price and your variable cost. So one of the items that they must provide is your selling price. The other item they must provide is your variable cost. They must also provide your what? Quantity sold. if they ask you to represent or to determine profit using probability distribution, again, they will give you selling price that they must provide and the probabilities. They must also give you what? Variable cost with the probabilities, the units sold, the fixed cost. So we're saying when you're dealing with a probability tree diagram, there is some certain information you must be done what? Given that is uncertain, and that is why you're going to be drawing a what? A tree diagram. And I want us to look at an illustration on the same, on a tree diagram. And the question I want us to talk about specifically is on April 2024. Let's go to April 2024. April 2024. The question we want to tackle is question 2A. And the company name is what? Joe Mwinzi. That is the name of that company. Joe Mwinzi, the management accountant of Vera Enterprises that makes and sells products Alloy, has made the following estimates. You have your sales, you have three conditions, which is the worst, the most likely, and the best. You have your probability of the sales. You also have your variable cost under the conditions that are worst, most likely, and best. You have your costs or variable cost per unit under those conditions, and you also have the probability of variable cost under those conditions. Additional information. The selling price of alloy product is 1,000 per unit. Fixed cost attributable to alloy product is 24 million. Vera Enterprises intends to achieve a target profit of 6 million. Using a probability tree, compute the expected profit of Vera Enterprises. Number 2, compute the probability that Vera Enterprises will fail to break even. Number 3, determine the probability that Vera Enterprises will not achieve the target profit. The target profit. So they're telling us to determine your expected profit using your tree what? Diagram. Remember, from the previous working, we know how do you get expected values? You simply take your variable, you multiply by your what? Probability. So even in this particular circumstance, to get our expected profit, we will take our profit, you multiply by your what? Probability. But you know, how do you determine your profit, class? Your profit, we've talked about it so many times. It is determined by your selling price minus variable costs. You multiply by your units, and then you subtract your what? Fixed cost. You subtract your fixed cost. They are telling us that the selling price is 100. Your variable cost has been provided, and various costs have been provided with various what? Probabilities. So it basically means you are uncertain of the true cost of the variable cost. The units to be sold after production, you have been given under various conditions, and they are probabilities. And so this is how you're going to draw this tree diagram. This is how you're going to draw this tree diagram. Let's start by determining the units. There, there, and there. Your units, you have 45,000 units with a probability of 0.3, and those are the worst conditions. That is worst condition. The next condition is when it is most likely. Most likely. And most likely, your probability is 0.6. Then you have the best condition. The best condition, you have a probability of 0.1. Of 0.1. 0.1. How many units are this of most likely? 50,000. And best conditions was how much? 55,000 units. 55,000 what? Units. We have represented the units to be produced and sold. So these are your who? Units. These are your units. The other uncertain item that we don't know about is your variable costs. Your variable what? Costs. And your variable cost, we will have it in 3 market conditions. 3 market conditions. Let's draw it nicely. 3 market conditions. The first market condition is 0.3, which is what? The worst. So let me write this here, the worst. The worst condition with a probability of 0.3, and your cost is 350. Most likely is the next market condition. With a price with a probability of 0.5, but a cost of how much? 400. You have the best condition with a probability of 0.1, with a price of how much? 550. You repeat this. Worst, your probability is 0.3. Most likely, the probability is 0.55. The best condition, your probability is 0.15. 0.15. Then we also need to analyze what? Worst, 0.3. Most likely, 0.55. The best is 0.15. Your prices are 350, 400, 550, 350, 400, 550. That is your variable who? Costs. These are the units, so these are your variable costs. Very important that you capture that. That is your variable cost there. Okay? Then we can then determine your contribution margin. Your contribution margin multiplied by the units will give us what we refer to as total contribution. Remember, how do you get your contribution margin? It is simply the difference between your selling price, and remember, your selling price was set as what? 1,000. Your selling price was set at 1,000. So to get your contribution margin, you simply take your selling price minus your variable cost. Minus your variable cost. And how will that be? You're going to take 1,000 minus 350. 1,000 minus 350. 1,000 minus 350. We'll say 1,000 minus 350. Then you multiply by the units. And how many units were you selling? 45,000. So please confirm that that is 45 million times 650. This is 29 to 50,000. So my values are in thousands. My values are in thousands. Then again, determine your contribution margin by taking your selling price 1,000 minus 400. Believe now you have understood that. Times your units, and your units were 45,000. 1,000 minus 550. How many units again are you selling? 45,000. 1,000 minus 350. Yeah, your selling price is not changing. You multiply by who? Your units now, for the most likely scenario, are 50,000. 1,000 minus 400. Again, your units are 50,000. 1,000 minus 550. You multiply by 50,000. That will give you your contribution. 1,000 minus 350. Your units under the best scenario is selling 55,000. 1,000 minus 400 by who? By 55,000. 1,000 minus 550 by who? By 55. Then we now get our who? Totals. We then now get our who? Totals. We need to get our totals. We get our totals. 600 by 45,000. That must be 27 million. 1,000 minus 550 by 45,000. That must be 20 to 50,000 times 50,000. That must be 32,500. That must be 30 million. 1,000 minus 550 by 50,000. That is 22,500. 1,000 minus 350 times 55,000. 35,750 million. 1,000 minus 400 by 55 is 33 what? Million. 1,000 minus 550 times 55,000. 24,750,000. That will give you your who? Contribution. That will give you your total who? Contribution, which is your contribution margin times your units. Then you then subtract your who? Fixed costs. So let's have our who? Fixed costs. And I will have my fixed cost in thousands of what? Shillings. So you need to indicate that. Your fixed cost, what were they saying? Note number 2. The fixed cost attributable will be how much? 24 million. So this should give you 24,000. 24,000. 24,000. 24 again. 24. 24. 24. 24. And lastly who? 24. Now with that, we then need to get our who? Profit. Remember they wanted us to get our what? Expected profit, which we know. For us to get our expected profit, we need to get our profit. We multiply by our probability. So let's start by getting our profit. 29 to 50, which is your contribution, minus your fixed cost of 24 million. This will be 5250. 27 million minus 24 million, that will give you 3 million. 20 to 50 minus 24 million, that will give you a negative profit of 3750. 32,500 minus 24 million, that is 8,500. That is 6 million. 22,500. Is that 1,500? Yes, it is. Minus 24 is 1,500. 35,750. Minus 24 million. That must be 11,750. 33 million minus 24 million. That is 9,000. 9,000 or 9 million. 24,750 minus 24 million. That is how much? 750. We then will introduce our joint probability. Our joint probability, which we simply denote as JPO. Why are we doing that? We are doing that so that we now take our profit by our joint probability to get our expected profit. Our expected profit. Your joint probability will simply take the probability of units, you multiply by the probability of your variable cost. For example, 0.3 by 0.9, 0.3 by 0, it should be 0.3, eh? The other one is what? 0.3. You multiply by who? 0.55. I'm indicating this because it is necessary, so that you together 0.3 by 0.15. Very nice. Must indicate this. 0.6 by 0.3. 0.6 you multiply by who? 0.55. That was 0.6 by 0.55. 0.6 by 0.15. Best 0.1 by 0.3. 0.1 by 0.5. 0.1 by 0.15. Sorry about that. We then get our joint probabilities now. Our joint probabilities. 0.3 by 0.3 is 0.09. Then 0.3 by 0.55 is 0.165. 0.3 times 0.15, 0.045. 0.6 by 0.3, 0.18. 0.6 by 0.55, 0.33. 0.6 by 0.15, 0.09. 0.1 by 0.33, 0.30. 0.03, 0.055, 0.015. Wonderful. Let's then get our expected profit. Our expected profit by taking your probability, you multiply by your who? Profit. Your probability, you multiply by your profit. So 5250, and this was in thousands of shillings. Remember that is in thousands of shillings. 5250 by 0.09. 5250 by 0.09, that is 472.5. 3000 by 0.165, 495. 3750 by 0.045. This will be 168.75. 8500 by 0.18. 1530. It is very, very necessary. As much as it looks exhausting and very involving, you need to do this. 1500 by 0.09. 130. 11750 by who? 0.03. 352.5. 9000. 55. 495. 750 by 0.015. 11.25. Once you've gotten the product of your probabilities and your what? Your profit to determine your expected profit, you then now get your totals. So you must get your what? Totals. And this, remember, is your expected who? Profit. Expected profit. So you now simply add 472.5 plus 495 plus 168 plus 0.75 plus 1530 plus 1980 plus 135 plus 352.5 plus 495 plus 11.25, which will give you 56.40. Which will give you 56 what? 40. 56.40. So therefore, we can say that, and this was a loss, This was a loss, 22 minus 24, that is a negative profit. The same case with this one. We have left out those negatives. Is there any other negative? That's a profit, a loss, a profit, and a profit. So let's compute this answer again because of the what? Of the negatives, of the negative profits. We left out that, but the good thing is that we have captured it. So let's add again. 472.5 plus 495 minus 168.75 plus 1530 plus 1980 minus, this is a negative, 135 plus 352.5, which was a positive, plus 495 plus 11.25, 5032.5. That will give you your expected what? Profit. That will give you your expected profit. That is the first part of that question. The first part of that question is saying, using a probability tree, compute the expected profit of what? Vera. The next part of that question, part 2, that was part 1. Part 2 of that question, compute the probability that Vera Enterprises will fail to break even. Compute probability that Vera will fail to break even. To break even. The probability that Vera will fail to break even is here. 0.045 plus 0.09. Why? At break-even point, your profit is equal to 0. Okay, so anything less than 0 basically means your company is not able to break even. And as you can see, with a probability of 0.45, your profit is negative. With a probability of 0.09, your profit is negative. So you have not been able to cover your costs. So this will be given by 0.045 plus 0.09. 0.09. It should be 0.045 plus 0.09, 0.135. You're not able to break even from here. The third part of that question, lastly, the last part of that question, determine the probability that Vera Limited will not achieve a target profit. Compute probability that Vera will not achieve. How much is your target profit? Your target profit, they were saying, was 6 million. 6 million. So where will you not be able to achieve your target profit of 6 million? That first is not achieving. You're also not achieving that you have achieved, that you have achieved, that you have not, that you have, that you have, that you have not. So we take the joint probabilities. The first one is 0.09 here. The second one is plus 0.165 here. The third one is already a loss, plus 0.045 plus, that is a profit of more than 6. That is also okay. That is a loss with a probability of 0.09. That is a profit of more than 6 is okay. That is a profit of more than 6 is okay. That is less than 6 million. So 0.015. So then what do? We simply now get the total. So for the company not to be able to achieve a target of what? Of 6 million profit, the probability is 0.405. 0.405. And that is all that is required in that particular question. That is all that is required in that particular question. All right. That is how you deal with probability tree diagram. So as far as your conditions of uncertainty is concerned, in the next lesson, we are going to talk about continuous or normal distribution method. Continuous or normal distribution method. And I would like for us to attempt a question. And from your previous illustration questions, you can attempt November 2017. So your assignment, this is an assignment, this is your homework, this is an assignment. So you can attempt a question of November 2017. November 2017. And the specific question is question 4A. BPO Limited. BPO Limited. BPO Limited. Right. So thank you so much. We can call it a day and then have a good time.